Alright, so let's start the Chapter 7 test review part 2. And I see the little red dot on the top is on, so we're good. So let's start with question number 50. Find the geometric mean of 7 and 28. So remember that geometric mean is, the way that I like to write it, is with this equation. But the other way we can write it is in this proportion, right? Because these are our means and these are our extremes. And the way we get the top one, the way that we get this one, is by cross multiplying these two, okay? So x times x is x squared, and a times b is ab. All right, so here, remember that this x right here is taking the place of what could be the geometric mean. So if it's asking us to find the geometric mean, that means that I do not have my x at the moment. So I'm going to solve for x squared equals, and now 7 and 8 are my a's and b's. So 7 times 28. So 7 times 28, if we use the calculator, 7 times 28 is 196. 196, and we could factor. So is that a perfect square actually? Let's see. Is 196 a perfect square? It is. It's 14. So x is equal. It's actually equal to positive and negative 14, right? But we know that a geometric mean is a length or a distance, so it can't be negative, so the only answer is 14. Okay, so now let's move on. Find the geometric mean of 8 over 3 and 54. So nothing changes. X squared equals 8b. X squared equals 8 over 3 times 54 over 1. So now we can cross multiply this 3 and this 54. What's the greatest common factor? It's 3. So 3 divided by 3 is 1. 54 divided by 3 is 18. So now I have x squared equals 8 times 18. 8 times 18, which is 144. 1 times 1 is 1, so we don't worry about that. And what's the square root of 144? It's 12. All right. So let's go to the next one. Now, this is where it starts to get more difficult, right? Remember that when your geometric mean is on the altitude, your A and B will be the two segments of the hypotenuse that were cut by the altitude. When your geometric mean is on your leg, like let's say this y right here was the leg, your A is now your entire hypotenuse, and your B is the segment of the hypotenuse that is adjacent to this leg. In this case, it would be 34. But if I was solving for the geometric mean here, like let's say this was Z, then my A would still be all of this, but now my B for Z would be 4. So here, my geometric mean is on my altitude, so it's x squared equals AB. What gets substituted into this x? Just x. So x squared equals, what's my A? Let's say it's 34, and my B could be 4. So now 34 times 4 is 136. If we square root, I know this can be square root of 4 times square root of 34. This is square root of 2 times square root of 17. And that's it. 4 comes out to give me a 2. This 2, there's no other 2's there, so this stays inside the radical. And this 17 is a prime as well. Like 2 and 17 are both prime, so they can't be factored out anymore. And there's no other 17's as well. So these two guys come back inside the radical, and the way they do that is they multiply to each other. So what's 2 times 17? 34. So my answer is 2 square root of 34. 34. Now here, I'm going to have two answers. I'm going to have to solve for x and for y. So remember that the geometric mean formula is x squared equals AB. Whatever goes on your x is whatever geometric mean you're looking for. We have three locations where the geometric mean could be located. It could be either on our altitude or on one of our two legs. So let's solve for this first geometric mean, the altitude. So this x is going to get replaced with x. So I have x squared equals, what's my a now? It's each segment, right? So 54 times, what is this little segment here? Well, if the whole hypotenuse is 50 and this piece is 45, what is this piece? It's just going to be 5. So 54, 45 times 5. So x squared equals, what's 45 times 5? 225. And the square root of 225 is actually a perfect square. It's 15. Okay, so now let's solve for y. Now when I'm solving for this y right here, it's that geometric mean is now on the leg. So what gets replaced into this x right here? A y. So now I have y squared equals AB. I don't know my y, so I'm going to push it down. What's my a? My a is my entire hypotenuse. So it's 50. And my b, is my b the 45 or the 5? Right now, because this is the leg that I'm looking for, this is the segment of the hypotenuse that is adjacent to this leg. So it is 5. Y squared equals 50 times 5 is 250. We can square root this into square root of 25 times square root of 10. And this can be broken down to square root of 2 and square root of 5, but there's nothing else. And this is a perfect square. What is the square root of 25? It's 5. So now this 2 and this 5 cannot be taken out, and they cannot be further simplified. So they just combine together to give us our final radical. And when they combine, they multiply. So what's 2 and 5? 10. 2 times 5? 10. So my answer is 5 square root of 10. All right, let's do this one. Now, this one's a little bit harder, right? Because your geometric mean, most of our geometric means have been a variable. I've had an x here, or an x here, or a y here. I've had it on the two legs or on the altitude. But now, my geometric mean, in other words, my x value is no longer just a variable. It is actually an expression. What expression? X plus 5. And where is this x plus 5 located? On the leg. So I have to treat this like a geometric mean question when my geometric mean is on the leg. So now what gets substituted into this x? It's going to be x plus 5 squared equals. Now when my geometric mean is on my leg, my a is my entire hypotenuse. So this entire hypotenuse is 11 plus x. This is the segment addition posture, right? Do not say 11x. That's wrong. It's 11 plus x, or the way I like to write it is x plus 11. Either way is okay. And now which piece of this hypotenuse is actually adjacent to this leg? Is it the 11 or is it the 8? Well, right now, I meant to say x. Which one is it, the 11 or the x? Right now, it's the x. So times x. Now, I know I made you guys write this on the board. This, solving for this. But if you weren't here, or I don't know why you wouldn't write it down if you were here, this is it. A plus b squared. Or this is an equation that helps you to more easily solve this. So what we're doing here is, let's look at this one over here. Let's look at this one. We're doing, what is a squared? A squared. What is b squared? B squared. Now the next step. What is a times b times 2? That's going to be 2ab. 2ab. So that's pretty much what we're doing here. So let's simplify this. What is x squared? X squared. What's 5 squared? Positive 25. What's x times 5? That's 5x times 2, 10x. Now let's keep going. This is distributive property, right? This is x squared and this is 11x. So now we have an equation that has an x squared and an x. So it looks like we're going to have some sort of quadratic equation question. So let's set everything equal to 0 and let's see what happens. If I subtract x squared and subtract 11x, what's going to happen here? These two cancel out, but what also happens here? These guys also cancel out. So now I'm not left with an x squared. So luckily, I'm not going to need to do a quadratic equation. So now, what is positive 10x minus 11x? Well, that's going to give us negative x, and then this 25 drops, plus 25 equals, what goes over here? Just 0. So now, I don't want my x to be negative, so I'm going to add it to the other side, so that now I have 25 equals x, or x equals 25. So that's my final answer. Which is right here. Okay, so here, once again, we have the same type of problem, right? But now my geometric mean is on my altitude, and now my geometric mean is another expression. So let's solve this one. So now x squared equals ab. What goes into my x? What's on my geometric mean? This altitude. So I'm going to have x plus 13 squared equals, when my geometric mean is on my altitude, my a and b are the two segments that were cut of the two segments of the hypotenuse that were cut by the altitude. So I have 52 times x, so 52x. Now let's do our trick to solve this. What's x squared? X squared. What's 13 squared? Positive 169. What's x times 13 times 2? 26x equals 52x. Now we have another quadratic equation question. So I'm going to try to make it in the format of x squared, of ax squared plus bx plus c equals 0, like this. I want to make things look like this when I have an x squared and an x together. So let's set it equal to 0. Minus 52, minus 52. So I have x squared minus 26x plus 169 equals 0. So now I need to come up with two numbers. So now I'm going to do the AC method. So 1 times positive 169. So what two numbers multiply together to give me 169 and add together to give me negative 26? I have 13 times 13, but I have to make both of these 13s negative, because negative 13 plus negative 13 gives me negative 26. Also, negative 13 times negative 13 gives me positive 169. So now, since the coefficient is 1, I can just go ahead and write it inside of here. Now, I gotta set both of those expressions equal to 0, but because they're the same thing, I'm only gonna get one answer. So I only really need to set 1. So let's set this one. X minus 13 equals 0. Add 13. So my x is equal to, what is 0 plus 13? 13. And that's my answer, 13. All right, so here, in this type of question, you guys are obviously going to write it, but here I'm not gonna redraw it. I'm just gonna go based on the drawing they already gave me. So they want you to find the rest of these remaining pieces. So I'm gonna first I'm gonna plug in what they gave me. So A is equal to 2, and S1 is also equal to 2. So now let's solve for S2. So S2 is a side length. Well, I can actually use this A to help me figure out this side length, because there is a relationship between this altitude and this segment. And what is that? That this altitude, right? What's the value of this A? This A can go right here on the geometric mean, right? Because our geometric mean can be on the altitude or on one of the two legs. So this X is gonna get replaced with a 2. And what's my A? Well, my geometric mean is on my altitude. My A and B are the two segments of the hypotenuse that were cut by the altitude. So I have this S1 and 2, and I have this B. So now what is 2 squared? 4 equals 2B divided by 2. So my B is equal to 2. And what's my B? My B is this S2 value. So my S2 is 2. Now, let's put 2 right here. So now my H is really easy, right? Because my H is just what? This whole thing. So what's 2 plus 2? That's 4. Now what's U1? So for U1, I do not like subscripts. This is a subscript. I don't like that. So what I'm going to do is change this U into an X. I'm going to change it to an X. So I'm going to solve, I'm pretty much solving for X, this leg. So now my geometric mean, what goes into my X? An X. So X squared equals, now when my geometric mean is on the leg, my A is my entire hypotenuse, which was what? 4. And my B is the piece of the hypotenuse that is adjacent to that leg, which is 2. So my geometric mean is X squared 8. So now this turns to square root 2 times square root 4. This square root 2 can come out. This stays. So my X is equal to 2 square root 2. And what was the same value as my X? It was also my S1. I mean U1. Right here. So my U1 is 2 square root of 2. Now, let's look at U2. U2 is the geometric mean. Let's call it Y. This geometric mean, what is its A? The A, Y is on the leg as well. So its A is the whole hypotenuse, which is 4. And what's its B? The leg, the segment adjacent to it. The segment of the hypotenuse adjacent to it, which is what? 2. So what do you notice about this Y and the previous X that we just did? It's the same exact thing. Has the same A and the same B. So my answer is the same. 2 square root of 2. Alright, so now let's do this one. That's a little bit harder, right? Alright, so once again, we're going to label our parts. So U1 is 5. S2 is 24. Okay, so now let's find S1. S1. Okay. So I can't use A to solve it because I don't have the value of A. I can't use U2, but I can use U1 because it's what? 5. And this U1 is where? On the leg. So that means that now what's going to get put into this X? This 5. So 5 squared equals, when my geometric mean is on the leg, my A is my whole hypotenuse. So it's going to be 24 plus S1. I'm going to change this S1 into an X because I don't like subscripts. So now I'm going to have 24 times X. Whoops, I apologize. Yeah, what did I do there? I was wrong. So, yes, this S2 is 24, but where's my geometric mean? My geometric mean is actually on the leg. So my A is my entire hypotenuse. So it's A is not 24, nor is it X. It's actually X plus 24. And what is my B? The segment of the hypotenuse that is adjacent to the leg, which is X. So now 25 is equal to X squared plus 24. I need to subtract 5 to put it in X squared plus 24. X minus 25 equals 0. Rainbow method. Negative 24. What two numbers give me 25 and add to give me positive 24? Negative 1 and positive 25. So I have X minus 1, X plus 25. And remember that you have to set them equal to 0. So X minus 1 set equal to 0. My X will be 1, right? Because X minus 1 equals 0 plus 1 plus 1. So X equals 1. And then this one will be negative 25. But we know that my X is a distance, right? This X is the distance, so it can't be negative 25. So the answer has to be 1. So my X, or my S1, is equal to 1. And now, what's my H? This X is what? 24. This X or S1 was 1. So what's the whole H? 25. What's 1 plus 24? 25. Now let's find U2. So once again, U2, I don't like subscripts. So I'm going to change this into a Y. So let's solve for Y. So now it's going to be Y squared equals AB. My Y, I don't know it. My A is my whole hypotenuse, which is 25. And my B is going to be 24. So Y squared equals, what's 25 times 24? $600. Now we can square root 600 pretty easily into square root of 6 times square root of 100. Square root of 100 is 10. So my Y is equal to 10 square root of 6. And now let's find my A. So let's find my A in purple. So now my A is my other geometric mean. So I'm going to have A squared equals A times B. I don't know my A. So what's my A? Well, my geometric mean is on the altitude. My A and B are each segment of the hypotenuse that each segment of the hypotenuse that was cut by the altitude. So I have 1 times 24. So A squared equals 24. Square root of 24, I have square root of 4 times square root of 6. This 4 turns into a 2. And by the way, guys, I know I didn't go over on the last one. This square root of 6 turns into square root of 2 times square root of 3. But there's no other 2 and there's no other 3, so they just get combined back into square root of 6. That's why I didn't even bother. I just did A equals 2 square root of 6, which is the answer right here. All right, so this is not hard. It's just very tedious, right? It takes a while, which is kind of annoying, but you know, you got to do it. Okay, so now this question, it's a lot of words, but I'm going to tell you what it means. You can read it on your own time, which I suggest. But it's asking you for this entire length right here. I think it says the height of the mountain or something like that. So now it's just a geometric mean question, because how do I know it's a geometric mean question? Because I have one big right triangle with an altitude starting at the right angle vertex, which is right here, going down at a 90 degree. So now, geometric mean question. What is my geometric mean? It is 3.20. So 3.2 equals, what's my A? My A is 1.81. And what's my b? Do I know my b? No, I don't. So I'm going to label it y. Or you know what? Let's label it h for height. Why not? Let's label this h. So times h. So now, what is 3.2 times 3.2? This is 10.24 equals 1.81h. Divide 1.81. So my h is equal to 5.65745. Remember I told you guys at the beginning of the year, never ever ever round your answer until that's your final answer that you're going to put on your piece of paper. This h, this 5.65745 is not the final answer. Your final answer is what? I only know this value right here is this h. I want this h plus this 1.81. So I'm going to do this plus 1.81. And that is my answer. So my answer, how did they want it? They want it round to nearest 100. So I'm going to write to you guys what I have in my calculator. A lot of it, 7.467458. So if we round it to nearest 100th, this is the 10th, this is the 100th. So if my 100th place is 6 and the next number is 7, is this 6 going to go up or is it going to stay at 6? It's actually going to go up by 1. So it's going to be 7.47. And that's my answer. Make sure you round correctly, okay? All right, this question is so easy because, okay, let's read it. The altitude to the hypotenuse of a right triangle. So let's draw a right triangle. The altitude to the hypotenuse of a right triangle divides the hypotenuse. What's the hypotenuse right now? This guy. So they're saying that there's an altitude that is dividing this hypotenuse into segments 7 and 28. Find the length of the altitude. So the length of the altitude will be what? This length, with this, which is x. This is everything we've been doing. So now my geometric mean. Where's my geometric mean? Here on the altitude. So x squared equals, when my geometric mean is on the altitude, my a and b are each segment of the hypotenuse that was cut by the altitude. So 7 times 28. What is 7 times 28? 196. And what's 196 squared? It is 14. So as long as you draw it, you'll be good to go. Okay. Oh, I put the same question twice by mistake. Okay, so let's go to 60. I put 59 twice. All right, so whoa. So 60. A classmate wrote an incorrect proportion, 3 over x equals x over 8, to find x shown to the right. Okay, so this is a geometric mean question, right? Because I have a big right triangle. I have a big right triangle with an altitude creating 2 smaller right triangles. So I know my formula looks like this. Or what's the other one? A and B. Okay, so let's see where this guy went wrong. He said 3 over x, which so far sounds good, is equal to x over 8. Let's do it in a different color. He said that is equal to x over 8. That's where he went wrong, right? Because where is this geometric mean at, guys? This geometric mean is on the altitude. That means that the a and b right here, so that means this, let's do it with this formula. what gets replaced with these x's? The geometric mean, which is what? X. So I have x over something, x under something, and x over something. And now, what is my a? Well, one of my a's is my 3, this segment, but the other one is this segment right here, which is not 8, it's actually what? 8 minus 3, right? Because if this whole thing is 8, and I already have a 3 over here, what does this have to be? 5. So that's where he went wrong. So let's look at which answer it was. Okay, let's look at why it was C. The altitude to the hypotenuse is the geometric mean. That's correct. Look, okay, sorry, let's just do the right one. The altitude to the hypotenuse is the geometric mean of the segment of the hypotenuse. 3 over x equals x over 5, right? What's the same thing as saying 5? X minus 3. So this is the correct answer. This one has x minus 3. Well, these are both wrong because it says x plus 3. So those you can take out. And even though this says x minus 3, this says the segment of the hypotenuse is the geometric mean. No, it's not. The only parts that can be the geometric mean are the altitude or the 2 legs. This is why I repeat things over and over, even though it's very annoying. Because when you've heard me say countless of times, the altitude and the legs are the only thing that can be the geometric mean. If you read this right off the bat, the segment of the hypotenuse is a geometric mean, you guys should be saying, what the heck? No, that's not what Mr. said. If I would have said that, Mr. would have, crashed out, because that's not what I say. It's altitude or the legs. Okay? So now we're doing 7.6, which I think is a lot easier. This is the side splitter theorem, corollary to the side splitter theorem, and the angle bisector theorem. So this is telling me that I have different ways to set up proportions now. So this proportion So now, the proportions that I could do to solve for my x are a bunch. I could either do 12 over 15 is equal to 6 over x. Or, for x. Or, I could also do 12 over 6 is equal to 15 over x. What's the only difference between these two proportions? I switched the means. So let's solve for the first one. Why not? Let's solve for this one. What is 12 times x? 12x. What's 6 times 15? 90. And now 90 divided by 12 is 7.5. If you use your calculator, notice how here they said type an integer or a decimal. So that means you can actually use a decimal. You don't have to have it as a fraction. So if you did want to do it as a fraction, you'd have to divide by 2. So you'd end up getting 45 over 6, but then you can actually keep going by 3. And you would get 15 over 3. Oh no, 15 over 2. So you don't have to do all this work because they asked you can leave it as a decimal. So you got lucky. This one you could just leave it as a decimal, 7.5. So now what about this one? Once again, this is the corollary to the side splitter theorem because I have how many parallel lines? I have 5. If I have parallel lines with 2 transversals going through them, then that means the segments that were created are proportional. What segments am I talking about? This is proportional to this, this to this, this to this, this to this. So the proportion I can set up is x over 6.6 equals 30 over 11. The other one I could have set up was x over 30 equals 6.6 over 11. There you go. And all I did was switch my means. So now this is 11x equals, what's 30 times 6.6? 30 times 6.6, that is 198. And 198 divided by 11 is equal to 18. So that's my answer, 18. That's it. It's not hard, right? It's proportions. It's cross multiplying. Now, this one's a little bit trickier, right? They want me to solve for x. So I always like to put my x first. So I'm going to say that x is corresponding to 14. Now, I know that this side right here is corresponding to 15. So I know something's corresponding to 15. I just don't know what this is, because the only thing I do know is that this entire thing is 27. So if this entire thing right here is 27 and this little piece is x, what does this bigger piece have to be? It's the whole 27 minus this x. So you would have 27 minus x. And now we can solve for that. What's x times 15? 15x. 14 times 27, so this would be 14 times 27 minus x. So 14 times 27. $378 minus 14x. I'm going to add 14x to this side so that I get my variables on one side and my constants on the other. So I'm going to have 29x equals 378. Divide by 29. Divide by 29. So my answer is a big decimal. Can I have it as a decimal? No, I cannot. I need to have it as an improper fraction. An integer, which is like 1, 2, 3, 4, 5, 6, -1, -2, -3, or an improper fraction. So I'm going to have to simplify this. So let's see. We can't simplify this because 29 is prime. So my only answer is 378 over 29. 378 over 29. Okay. So now this question. Use the figure at the right to complete the proportion. So here, CF is corresponding to something. So CF is corresponding to something. So I'm going to leave that in blue. Now let's go to red. FJ, where's FJ? FJ is corresponding to AJ. To this. Okay, right there. So if this is corresponding to this, then what do you think this is corresponding to? AC. Right here. AC. So now the answer is AC because of what? What is this? What do I have here? I have an angle bisector. And if I have an angle bisector, then I know that the side lengths that were, the segments that were created by those parallel lines on that angle bisector are going to be proportional to each other. So triangle angle bisector theorem. All right. Once again, same thing here. Look, the triangle angle bisector theorem, which tells me that I have a bunch of different ways I can line this up. I can say this is corresponding to that. 10x minus 2 corresponding to 7x is equal to 9x over 6x. Or I could have 10x minus 2 is corresponding to this, and 7x is corresponding to this. I'm just going to leave it like this because I feel like you guys should already know how to do proportions. So let's solve for it. 9x times 7x is equal to 9 times 7 is 63x squared. right? Because an x times an x is x squared. That's what's going to get people here. So now here, what is 6x times 10x? Well, okay, let me write this down. 6x, 10x minus 2. So now let's distribute. So I still have 63x squared equals 60x squared. And then this becomes negative 12x. So now I'm going to subtract 60x squared. Subtract 60x squared. So I'm going to have 3x squared equals negative 12x. Now, I can actually divide both of these guys by x to get rid of this x and get rid of one of these x's here. So now I'm going to have 3x equals negative 12, and now I can divide 3. So my x is equal to negative 4. The reason why I didn't do quadratic is because I didn't have a c, guys. I didn't have like, right? I had this right here. I had this right here, but I didn't have a c. I didn't have a constant. So that means I cannot set this equal to 0 and do the whole what's it called? The AC method, right? The quadratic. I couldn't do that. So I just had to straight up solve for x the normal way by simplifying and dividing and getting rid of things. So my x is negative 4. Now, well, this is weird. Because if this is negative 4, then it's telling me that these side lengths are going to be negative 27. Yeah, that's weird. Oh, well, that's your only answer, so you can only do negative 4. Okay. Notice how it says round to 1 decimal place as needed. I do not believe that you need to put negative 4.0. I think if you put negative 4 alone, it'll work. But I'm going to double check. I'm not even sure if this question is on your test, but I'm going to double check to make sure that it will give you the right answer if you put negative 4 or negative 4.0. But if you just want to make sure, if it says round to 1 decimal place is needed and there's no decimals at all, you just put 0.0. Okay? So remind me about that. Now, this question is hard. So let's do this question. So solve for x. So x is on the triangle, of course, but what do I have here? I have an angle bisector question right here. So this angle bisector tells me that this x is proportional to this 3. So I have x over 3 is equal to, this is what? 5 over, I don't have anything here. So let's call this y. So can I solve for x and y at the same time? No, I cannot. So I'm going to have to solve for y first before I can solve for x. So now let's solve for y. So I want to solve for this y. There are 2 theorems I have here. Not only do I have the triangle angle bisector theorem, I also have the side splitter theorem right here, which tells me that now this 2 is corresponding to what? 3. And that this 3 is corresponding to this y. So now I can solve for y here. So what is 2 times y? 2y. 3 times 3 is 9. So now I have y equals 9 over 2. So now I can go ahead and turn this y right there. So now I have 5 over 9 over 2. So now we can cross multiply the x and figure out my x value. So now let's do a different color. What is x times 9 over 2? 9 over 2x. What is 3 times 5? 15. Now, normally, this x is being multiplied by this 9 over 2. So our first instinct is to divide, but I know that I can do something else besides dividing a fraction. I can multiply by that fraction's reciprocal, which is 2 over 9. So now my x, 2 over 9. So now I can cross simplify this 15 and this 3. The greatest common factor is 3. So what's 9 divided by 3? 3. What's 15 divided by 3? 5. What's 5 times 2? 10 divided by 3. There, it can't be simplified, so it's just 10 over 3, which is right here my answer, 10 over 3. Okay. So determine whether the red segments are parallel. It's kind of hard to see it right here. Yeah, you can see it better like that. But these are the red segments. So they're asking me, are these segments parallel? So I'm not even going to look at my multiple choice right now. So in order for these segments to be parallel, I need to know that these sides are what? Proportional. So let's set a proportion, and if these side lengths are proportional, then I can go ahead and say that they are parallel. So now, let's do 20 is corresponding to 24 is equal to 36 over 64. Okay, so honestly, simplifying this is going to be really hard. So let's just do it the way we did it in the beginning of the quarter, which is just cross multiplying. So 20 times 64 is equal to 20 times 64 is equal to 1,280. 24 times 36 is equal to 864. Are these proportions equal? Are these is this proportion valid now? No, because is this equal to this? No. So then are these lengths proportional? No, they're not. Why not? Because the segments that were created by the intersection of these lines are not proportional. So let's see which one sounds like that. Let's look at A. The segments are not parallel because the conditions of the converse of the side splitter theorem are not satisfied. So if the side splitter theorem tells me, hey, if your lines are parallel, then your segments are proportional. So the converse would tell me, if your side lengths are proportional, then my lines are parallel. Did that get satisfied? No, it did not. So that's the answer. The converse was not satisfied. Now, last question, and this is a tricky one. So let's read. Okay. An angle bisector of a triangle divides the opposite sides of the triangle into segments 4 and 7. So automatically, I'm doing this. I have an angle bisector, right here, angle bisector. And the opposite segments are 4 and 7. A second side of the triangle is 10.5. So let's say this side is 10.5. Find all possible lengths for the third side of the triangle. So that means this third side of the triangle could be x. So let's solve for this x right here. This would be what? 10.5 over 4 is equal to x over 7. That's one way to solve it. So let's solve this. So 4 times x, 4x. 7 times 10.5. This is 73.5 divided by 4 divided by 4. So my x is equal to 18.375. But how 18.375? How do they want me to round? Round to 1 decimal place as needed. Okay, so to 1 decimal place, that means the 3. So what's the number after the 3? 7. So is my 3 going to go up to a 4 or is it going to stay at 3? It's going to go up to a 4 because this number is 5 or greater. So my answer for the first x is 18.4. And why do I say the first x? Because this tells me, hey, a second side of the triangle is 10.5. Did they specify which side of the triangle? Did they say, hey, the side of the triangle adjacent to 4 or the side of the triangle adjacent to 7? No, they just said a side. So there's a world that exists where this triangle has the 10.5 on the left-hand side, and there's another world where this triangle has the 10.5 here, and the x, let's put y, and the y here. Or I guess we can put x, x here. So now let's solve for this x, the blue x. Let's call it the blue x. So now this proportion would be what? X over 4 equals 10.5 over 7. So we have a completely different proportion than the one we had previously. And that's the point, is that we don't know where this third side is, so we have to test for both of them. So now 7x, 4 times 10.5 is going to be 40. I think I know this. I want to do it in my head. I'm too tired. Okay, 10.5 times 4 is 42. So now divided by 7, x equals 6. And remember, they want you to round to 1 decimal place, so just put 0.0, just to be safe. If you get a whole number and they want you to round, just put 0.0. So there's your answer, 6.0. So that was pretty much it. So I know this was shorter, but these are very important questions. And remember, half of your exam is going to be just on 7.5 and 7.6, geometric mean, and all this stuff, this additional properties of proportions. You should already know how to do most of these proportions. It's just about setting it up and understanding when to use what. So, good luck. You guys have your exam before Christmas break. So I'll see you guys in class. If you have any questions on any of these, you just remember to come to class ready to ask me, just in case we have some extra time. All right, bye.